So let's learn more about LAM research. Maybe I should buy a stock, buy or several stocks of this company tonight. This article is from LAM Research themselves, and the title is "Virtually every leading-edge device has been made using our equipment." Advanced microchips are in many of the familiar products we use every day, from mobile phones to computing devices to entertainment systems and increasingly smart cars. Electronic products are everywhere, and life without them is unimaginable. Creating the tiny complex chips used in these devices involves the repetition of a core set of processes and includes hundreds of individual steps. For successful production, semiconductor manufacturers require sophisticated processes and fabrication equipment. We work closely with customers to deliver the products and technologies needed to enable their success. By offering critical chip processing capabilities, our products provide a vital link between the visionary designs for the latest electronic devices and the companies that produce them. Our solutions. Market demand for faster, smaller, more powerful, and energy efficient electronics is driving the development of new fabrication strategies that enable producing advanced devices with fine, closely packed features and complex 3D structures. Creating the cutting edge microprocessors, memory devices, and numerous other product types in demand today is extremely challenging and requires continuous innovation to deliver capable processing solutions. Through collaboration and drawing on multiple areas of expertise, LAM continues to develop the new capabilities required to manufacture these increasingly challenging devices. Our innovative technology and productivity solutions deliver a wide range of wafer processing capabilities needed to create the latest chips and applications, from transistor interconnect, patterning, advanced memory and packaging to sensors, to transducers, analog and mixed signal, discretes, and power devices, and optoelectronics and photonics. Interesting. See our solutions. Okay, later. Our processes, semiconductor processes used in the manufacture of today's most advanced chips, are challenged to literally push the limits of physics and chemistry with their nanoscale features, novel materials. Here, novel materials is just like rare earth minerals, right? Not ordinary materials, not water, iron, just simple silicon. It's just novel materials. That's a good word, right? Like a lithium, isodium, peptomium, and increasingly complex 3D structures, meeting the ever-changing fabrication demands of new chip designs requires precision control at the atomic scale. To ensure those new process technologies are production ready when new chips head to the fab, our scientists and engineers stay abreast of our customers' manufacturing needs. Our broad portfolio of market-leading products for thin film deposition, plasma etch, right? You need to etch your design into the wafer using plasma. Photoresist strip and wafer cleaning are complementary processing steps used throughout semiconductor manufacturing. To support advanced process monitoring and control of critical steps. Our product offerings include a line of high-precision mass metrology systems. What is metrology? Metrology, we know the metrology, but metropolis, metrology. Science of measures and weights. Metrology, meter, right? Meter, liter, meter, weight. Metrology, 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 metrology is a scientific study of measurement. It establishes a common understanding of units critical in linking human activities. Metrology. Metrology. So let's go to our solutions, right? Their solutions. Enabling next generation technologies. Okay, so I'll read it later. Thanks for listening. Bye-bye. Today is Wednesday, October 22nd, I think. Wait a minute. Yeah, 22nd, 2025. I'm just lying down on the in my bed, but actually floor, ready to hit the sack virtually, go to bed. So I'm gonna finish this article, this section, so that I could finish things up on my research on LAM Corporation. They have a LAM research center in Korea. I would like to know more about the company and see whether I like it or not, whether they have a job opening for you and me, or what they are doing in Korea, right? They are American company. Samsung corporations and SK Hynix, they use ASML products, but I'm sure there are many other semiconductor equipment suppliers for those companies, including LAM. So let's find out what their solutions are used in the semiconductor industry. I read a portion of the all the information about the company this morning, but I had to go to work, so I stopped, and I'm gonna resume reading the rest of the information about the company. So here I am. I turned off all the lights, and I'm just lying on the floor with the blankets underneath me, and thinner blanket on my upper body. So I'm just relaxing, but I cannot resist my urge to know more about this company. Enabling next generation technologies. Market demand for faster, smaller, more powerful, and energy efficient electronics is driving the development of new fabrication strategies that enable producing advanced devices with fine, closely packed features and complex 3D structures. Creating the cutting-edge microprocessors, memory devices, and numerous other product types in demand today is extremely challenging, right? Now I'm just turning my body 180 so that I could read this article with more attention. I'm just lying on the floor with my belly on the floor. Creating the cutting-edge microprocessors, memory devices, and numerous other product types in demand today is extremely challenging and requires continuous innovation to deliver capable processing solutions. Through collaboration and drawing on multiple areas of expertise, LAM continues to develop the new capabilities required to manufacture these increasingly challenging devices. Our innovative technology and productivity solutions deliver a wide range of wafer processing capabilities needed to create the latest chips and applications, from transistor interconnect patterning, advanced memory and packaging, to sensors and transducers, analog and mixed signal, discretes and power devices, and optoelectronics and photonics. Source, fin, gate, drain, transistor. Transistors, the brains of a chip, are tiny switches that control the flow of electricity, and there can literally be billions of these on a single integrated circuit. Demand for smaller, more powerful electronics is driving the development of new transistor architectures like 3D FinFET designs and the use of specialty materials such as high-K metal gates. These in turn allow continued shrinking of device feature sizes, with the dimensions for the latest transistors now at the atomic level. They are extremely challenging to manufacture. To ensure the high performance expected of these advanced devices, manufacturing capabilities that deliver exceptional precision and control in forming the tiny features are needed. View our transistor solutions. Interconnect, copper, dielectric, interconnect levels. The interconnect makes up the intricate wiring that connects the billions of individual components. Transistors, transistors on a chip. As smaller and smaller devices are packed closer together, more interconnect levels are needed, and connecting everything becomes increasingly challenging. In fact, as the shrinking of feature dimensions has continued, interconnects are now becoming the speed bottleneck in today's most advanced chips. As a result, techniques that minimize resistance of the metal connections and novel dielectric materials that boost insulating capacity are needed. To produce the latest high-performance electronic devices, advanced interconnect structures involve narrow geometries and complex film layers, which require increasingly flexible and precise process capabilities. View our interconnect solutions. Initial spacing of mask. Spacer structures around the mask. Final spacing of features. Spacer structures. Initial spacing of mask. Spacer structures around the mask. Final spacing of features. Patterning. Patterning involves the set of process steps, including lithography, deposition, and etch, that create the extremely small, intricate features of integrated circuit. With each new generation, device dimensions continue to shrink. For advanced structures, these feature sizes can be too small and or packed too closely together for conventional lithography. The step that transfers The chip designs intricate detail from the mask template onto the wafer. To compensate, chip makers are using advanced techniques like a double, quadruple, and spacer-based patterning involving multiple masks and process sets. Even as these processes ease lithography limitations, they create new demands for exceptional process precision and film quality in order to accurately produce the fine, dense features required. View our patterning solutions, bit lines, contacts, gate stack. Advanced memory. Memory cells, the chip components that store electronic data, include short-term volatile such as DRAM and long-term non-volatile such as flash storage types. DRAM is the mainstay for working active memory, while flash memory is used to store large amounts of data in a compact form. To increase device density for more storage capacity, DRAM features continue to shrink, and NAND flash has moved to 3D architectures, which raise additional processing challenges. For example, the numerous layers in 3D NAND are vulnerable to stress, and any imperfections in the high aspect ratio channels can create electrical shorts and interference. Production of few memory types that bridge the gap between active and storage classes is also difficult due to the use of novel, hard-to-process materials. As a result, exceptional process control, flexibility, and productivity are needed. TSV, packaging. Packaging refers to the process steps that form the protective enclosure around the finished chip and create the external connections for input-output. Consumer demand for smaller, faster, and more powerful mobile electronics is driving the development of alternate packaging approaches. Strategies include wafer-level packaging, where chips are packaged while still on the wafer, then separated using bumping, redistribution layers, and fan-out packaging approaches. Scope out, fan-out, make-out. Another technique is the use of through silicon vias, right? TSVs, vias, viaduct, right? Which are conductive pillars of metal that connect stacks of chips. These strategies generate multiple challenges for the processing steps involved, such as managing a range of feature shapes, multiple material types, and strict thermal budgets. Sensors and transducers. Transducers are devices that change some type of energy, such as light, motion, heat, or a chemical reaction from one form into another. For example, actuators are a type of transducer that convert energy into motion. When the output of a transducer converts the energy to a readable format, an analog or digital representation, it is called a sensor. Many types of transducers and sensors are used to convert and measure signals generated in the environment all around us, and their applications continue to grow. While producing these specialty devices does not necessarily require the latest generations of processing equipment, it does require the development of processes to support many unique device designs. Also, some of the fabrication steps involve materials not used in other device types, such as piezoelectric thin films. As a result, equipment technical capability, reliability, productivity, and overall cost effectiveness are critical. Analog and mixed signal. Analog electronics are devices with continuous variable signal, while digital electronics provide discrete signals and differentiate only two levels, such as on and off. As the name implies, mixed signal devices contain both analog and digital circuits. Mixed signal designs are cost-effective solutions commonly used to build consumer electronics applications, and this group of specialty devices has been dramatic growth has seen dramatic growth with increased use of smartphones and other portable technologies. Processing equipment that provides high reliability and productivity cost effectively is needed for the economical manufacture of analog and mixed signal devices. Discrete and power devices. Wow, that's damn long, but we're almost there. Despite discrete devices are single semiconductors like diodes or transistors, power transistors are an important class of discrete devices. Okay, and are used in a range of applications to regulate voltages, help lower power consumption, and reduce heat generation. For example, they are essential components in circuits aimed at extending battery life in portable electronics. Emerging wide band gap power devices, for example, GaN and SiC, offer both low and high power applications at higher frequencies, addressing consumer electronics as well as higher power applications in the power grid, energy, transportation, and automotive sectors. Examples of key power devices based upon silicon or wide bandgap materials include power diodes, thyristors, power metal oxide semiconductor field effect transistors, MOSFETs, right? It's a metal oxide semiconductor field effect transistors, and insulated gate bipolar transistors. These types of specialty devices require low-cost manufacturing from reliable high productivity and cost-effective equipment. Optoelectronics and photonics. A photonic integrated circuit, PIC, also known as the integrated optical circuit, is similar to an electronic integrated circuit. However, instead of using only electrical signals to transmit information, these optoelectronic devices use both electrical and optical signals. The use of optics enables more bandwidth and faster connectivity while reducing power costs. Optical components are well established in telecommunications. I work for Korea Telecom, so I know about this, right? And are technologies that provide connectivity for homes. FTTH, fiber to the home. The growth in data center applications has greatly increased the demand for PICs since they enable more efficient system architectures, significantly reduce energy consumption. What is it? A NAS ask ASCIC ask, and what's other competitive technology as opposed to NAS? It's all optical, right? I forgot about it. SCSI, NAS. Ah, man, I forgot the word. As such, the use of optoelectronic systems is expected to continue growing and requires cost-effective, reliable manufacturing solutions. Okay, it's just technical introduction, right? And we'll go to careers, products, right? Our solutions, processes, products. Let's go to the products, what they are doing, right? Filter, Akara, Alta's product family, Corona's product family, Dextro, DSIE product family, DV Prime and DaVinci product families, EOS product family. I wonder what EOS stands in the industry, but it's Ethernet over SDH in the telecom area, Flex product family, Gamma product family, Callisto product family, right? Meteo product family. A lot of them, man, a lot of. But most importantly, let's go to careers to see if they have jobs, right? In your career, let's prove what's possible. Get personalized job recommendations. Wow, 365 jobs available. Well, I'm a telecom salesman, so maybe if you do have anything that is related to telecom, I'm the guy, man. Please contact me. I'm available 24/7, right? Right, that's it. Thanks for listening and have a great LAM day.